We're going to pick up with example 3, and I know some of this has already been worked out. I think we ended it here yesterday, and then we used the quadratic formula to get to this point. And then to find these two answers, I took negative 18 plus that radical divided by negative 32 got me that. Negative 18 minus that radical all divided by negative 32 gives me this. This is my answer, though, of how long it takes to hit to hit Anna, because 0.046 is like a millisecond. I mean, not literally a millisecond, but it's a very, very short span of time. And she's launching it upward at 18 feet per second. She's not like chugging at her. So 1.078 seconds is probably more a correct feature. Usually you're going to get a negative answer and a positive answer, and then you just always stick with the positive answer. Now, the question, does the piece actually hit her if Anna is standing 13 feet from Gabby? This piece would actually hit her because you can see that the rate it's going is 18 feet per second. So since 18 feet is more than the second here, or this is more than 1 second, and 18 feet would be at 1 second, then you can assume that, yeah, it did hit Gabby 13 feet away. Okay, for example 4, Selena and Emily have decided to learn how to harpoon fish. They need to practice their skills, so they head out to a local barn and stand in the loft, which is 25 feet above the ground. They're aiming for a stack of hay on the floor of the barn, which is 2 feet off the ground, and they throw the harpoon at an average speed of 26 feet per second. How long does it take the harpoon to spear the hay? Would this be quick enough if a fish senses the danger in 0.5 seconds after launching the harpoon? Okay, so again, we know that we want to deal with the feet equation, so this is the one I'm going to write down. Okay, I'm going to plug in the information that I want. I want to hit the stack of hay on the floor of the barn that's 2 feet off the ground. So 2 is my desired height. I'm looking to see how long it's going to take, so I know I'm going to keep my t squared. V sub O is how fast it's going, and since they're throwing downward, it's going to be a negative 26. And my initial height is 25. Okay. Get everything equal to 0. And then we're going to go ahead and put it into the quadratic formula. Okay. Punching out the radical, I get negative 26 squared minus 4 times negative 16 times 25, and that gets me 2,276 all over negative 32. Okay. Now, in this case, I'm going to get two answers. One of them is going to be a negative answer, one of them is going to be a positive. The negative answer is going to occur when I take 26 plus that radical, because that's going to be a positive number, divided by a negative number. So I'm going to actually skip that one. I'm going to take 26 and subtract that radical, and then divide that by negative 32, because then a negative divided by negative is a positive. And you get a time of 0.678 seconds. Okay? So would this be quick enough if a fish senses danger in 0.5 seconds after launching the harpoon? And you can say, no, it wouldn't be quick enough. The reason for that being because 0.678 is greater than 0.5. Okay, so tomorrow you're going to get a chance to practice these types of problems along with the other 4 type problems. I want you to go ahead and flip. Okay. And we're going to do a couple of these, probably up to example 3 if we have enough time. Your last standard is you can write the equation of a quadratic given its zeros or its vertex. Our last standard focused on working backwards, or this last standard, focuses on working backwards and how to find equations of quadratics by hand giving particular information. All we've been doing up to this point has been solving and finding the zeros. Now our goal is to start with information and work backwards to get the original equation. There are two types of information that can be given to us about a quadratic. They are the vertex and the intercepts. Remember when I told you these points are considered the most important points or the key features. Okay, so we're going to write down each form as a reminder. Standard form is ax squared plus bx plus c. Vertex form, a times x minus h plus k. And another reminder here you might want to write down, hk is the vertex. Intercept form, a times h minus p times, x minus p times x minus q. P and Q are your x-intercepts. Okay, so the type of information you're given will direct you in how to start finding the equation. For example, example 1, the information that I'm going to give you about the quadratic that we're going to write is that we're going to write an equation of a quadratic given the vertex 5, negative 2, and it passes through the point 7, 3. Okay. So what you need to be aware of in these situations is each one of these numbers represents something that you're going to be plugging in. And the equation or the form that you're going to use to plug in up here is that vertex form. And I know I have to use the vertex form because they gave me the vertex. Alright, so the vertex, that's my h and my k. The point is just my random x and y. So I have hk, I have an x and a y, and so what I'm going to do with those four values is I'm going to plug them in, and then I'm going to solve for my missing value, which I have nothing to plug in for, which is a, and then we're going to rewrite at the end. You did something very similar to this when we did absolute value function, so it should be familiar. So I'm going to plug in 3 for y, 7 for x, 5 for h, and negative 2 for k. Then we're going to go ahead and simplify. I'm going to simplify the parentheses first. So 7 minus 5 is 2. 2 squared is 4, so that's 4a. Add 2. So my a is going to be 5/4. So you end up getting the equation 5/4, because that's your a. And then we're going to plug back in your vertex. The reason we don't plug your x and your y back in as well is because this is just one point. Your equation needs to represent every single point. So you use that one point and plug it in to find a, but then once you find a, then you plug a in and your h and your k, and that becomes your equation of the quadratic that was described. Okay, we're going to do something similar for example 2. So write an equation of a quadratic given the x-intercepts, I don't know, 8 and negative 4, and it passes through let's say negative 1, 9. Okay. Because they give me the x-intercepts, I know I'm going to start with using the intercept form. And again, each one of those four values has a place. So the 8 and the 4, that's my P and my Q. The -1 and 9 are just my random X and Y. So again, you're going to be plugging these values into the form and then solving for A. So we have 9 A times -1 minus 8 times -1 plus 4. So you plug in 8 for P, -4 for Q. That's why it changed to a positive, because you're subtracting a negative. And then -1 for both the X's. Then we're going to simplify. -1 minus 8 gives me -9. -1 plus 4 gives me 3. So we get 9 equals, that becomes -27A. And so A is going to be -1/3. And then to write my final equation, you plug in -1/3. And then the two key points that they give you, which are the P, which is 8, and the Q, which is -4. And that's your final answer there. Okay. I'm trying to look at the time here. Hold on. Okay. We have time for example 3, and then we'll hold on off on the 4-type problems at the bottom. Okay. Let me just make sure. Yeah. All right, for example 3, we're going to write an equation of a quadratic given 3 random points. 5, 2. Let's go 2, 10, and -4, -7. I think. Yeah, that'll work. Okay. Now, when you're given 3 random points, notice that none of these are identified as the vertex or as the x-intercept. So this is something we could view as just some data. I do know that they want me to write an equation for a quadratic. So then we're going to go to a previous skill that we've learned, which was the regression stuff. We're going to use the regression capabilities of our calculator to input these 3 points and come up with a quadratic. So we have the x values 5, 2, and -4. And they pair up with the y values of 2, 10, and -7. Then I don't need to plot them because I know I want a quadratic equation. So then we go to the quadratic regression. I'm going to put in list 1, comma list 2. And you end up getting that equation. And so we write that down. Y equals, the A value is -0.611, B value is 1.611, and that last one. Okay, so those are the 3 types of quadratics that use each form that we've been dealing with, and how to write equations for each form. And then we will pick up, maybe in a homework video over the weekend, on these 4-type problems that we can practice on Monday. Okay, this is Chris Cross signing off.